English is such a strange language. I'm tempted to call this particular circuit an adder, but you might think I was talking about a venomous snake. I could also call it an inverting summer, but then you might think that had something to do with climate change. So, in any case, what this circuit does is it effectively adds the voltages at the multiple inputs. Now, here I have shown 3 voltage inputs. You could have 2, you could have 7. I have personally built circuits with about 10 or 12 inputs that are all added together. Now, in this particular case, each resistor is a separate value, and the weight with which each voltage is added in depends on the value of resistors chosen. If you simply wanted to add everything up with equal value, you could make all of the resistors the same and you would just get an equal valued sum of the input voltages. One possible application of this circuit would be in an audio mixer, for example, where you are mixing different audio signals to generate an overall sound. In that case, you would probably either make R1, R2, and R3 variable resistors, or you might put a potentiometer on the inputs, and we'll talk about that in a subsequent video, how to adjust inputs individually. But let's do a quick analysis here. Again, we've got negative feedback, R sub F, and therefore the big node right there sort of in the middle of the circuit connected to the inverting input is a virtual ground. So all of those resistors are connected to a virtual ground, so you can easily determine the current through each of the resistors on the left. The current through R1 is going to be V1 over R1, and then V2 over R2, and then V3 over R3, and if you had more resistors, it would be a similar thing. Now, all of those currents from the input voltages are squirted into that node where all the resistors and the inverting input of the op-amp are connected. Those currents cannot enter the op-amp itself, therefore they all have to go through R sub F. In other words, those 3 currents, 3 in this case, those 3 currents are added together and squirted through R sub F. For this reason, that big node connected to the inverting input is often called a summing node, because it sums the currents from the inputs and forces the sum of those currents to go through R sub F. Now, what you've got here is you've got those 3 currents, and then the voltage across R sub F is simply RF times each of those currents, the sum of those. But now, one potential problem with this circuit is that this is an inverting configuration, so V out is actually the negative of the voltage across R sub F. So what you get at V out is minus the sum V1 times RF over R1 plus V2 times RF over R2 plus V3 times RF over R3, and if you had other input resistors, you would have some more terms in there. So you've got a sum of those voltages, V1, V2, V3, each scaled by a separate factor. Now, like I said, if you just wanted minus V1, minus V2, minus V3, minus V4, whatever at the output, you could just make all of those resistors the same, and the RF over R1 term, or whichever resistor it happened to be, would just be 1, so you get the negative of the sum of those voltages. In some cases, the inversion of the input voltages is not important. For example, if you are building an audio mixer, in general it's not important because your ear is not sensitive to that inversion. You hear the same thing whether the waveforms are inverted or not. In some cases, for example, if you are using these voltages as control signals, that inversion might be important. If you don't want the inversion, you could always follow this circuit with a unity gain inverter, just a standard inverting amplifier with both resistors equal, and that would flip it back over and you get the positive sum instead of the negative sum. For that matter, if you wanted to add some voltages, some of which you wanted inverted and some of which you did not, you could do it this way. The ones that you did not want inverted, you wanted to come in as positive voltages, you could connect up to an inverting summer, just like this one, similar to this one, and then you could follow this with another inverting summer. The output of this first inverting summer would go to one of the inputs of the second inverting summer, and any other voltages that you wanted to come in as negatives could also be connected to that second inverting summer. And so when it went through that second inverting summer, the first bunch would get flipped over positive, and the ones that went directly into the second one would still remain negative. Very useful circuit, the inverting summer or the inverting adder. We will almost certainly see this basic circuit pop up again later in this course in some other context, but for now we need to move on and look at a differential amplifier.